Here's a little bit more help on today's assignment, Chapter 9, Section 5, exploring similar solids. First, let's take a look at the relationship between the dimensions of a square and the area of a square. Turn your head sideways to look at it. So the area of a square, the formula is s squared. The square that I'm showing you here, the side length is 5, so 5 squared equals 25. Let's say I doubled the dimensions, multiplied it times 2. That would mean 5 times 2 times 5 times 2, which is 10 times 10, which equals 100. If you look at the relationship between the area of the first square, which is 25, and the area of the second square, which is 100, that is times 4. And if you took Calvin, the same holds true for a rectangle. If you had a rectangle with the dimensions of 5 and 3, the area for that would equal length times width, which equals 5 times 3, which equals 15. Let's say I doubled the dimensions and I took 5 times 2 and 3 times 2. Sorry that you can't even see what I'm writing because my hand is covering it up. But I really did take 5 times 2 and 3 times 2, which equals 10 times 6, and 10 times 6 equals 60. If I look at the relationship between the original rectangle area, which is 15, and the area of the second rectangle, that's 60, the relationship again is times 4. Therefore, any time that you double the dimensions of a shape, the area of the shape will be times 4. Let's see how that relates to volume, or what you think it would relate to volume. So we'll go with our same square and the same dimensions. It has a side length of 5, except now it's a cube, so it has all of the side lengths of the cube are 5. And the formula for a cube is s squared. Volume equals s squared. If you take that volume and use the 5, it would be 5 times 5 times 5. Which is 125. What if I asked you to double the dimensions and tell me what the new area, or the new volume, would be? That means you would take 5 times 2 times 5 times 2 times 5 times 2, which equals 10 times 10 times 10, and that equals 1,000. The relationship between 125 and 1,000 is times 8 this time, not times 4 anymore. And that's because we have 3 2's, because it's cubed instead of squared. So it's 2 times 2 times 2, which equals 8. So anytime you have the volume of a shape and you double the dimensions, the volume will be times 8. So what happens if I want to triple the area, or have any other sort of number besides doubling it? I'll take my square. 5 squared equals 25. And let's say in this case I wanted to multiply the dimensions times 3. You're just going to take 5 times 3 times 5 times 3. 3 times 3 is 9. Therefore, the relationship should be 25 times 9. We can check that by multiplying 5 times 3 times 5 times 3, which is 15 times 15. So the area should be 225. Let's see if it is when we take 15 times 15.
These don't make sense.
15 times 15 is 225, so it works. This works for any dimension change that's being asked for. And you can use n as the variable for whatever the dimension change is. If you have area and you're getting a new area, just take n, whatever the dimension change is, n times n. And for volume, whatever the dimension change is, n times n times n. And that will always give you your new dimensions, your new area and volume. So let's look at number 8. The radius is 2.4 and 4.8. And then they also give you the surface area of 356 and the volume of 507. First of all, find the relationship between the two radiuses that you are given, and that is 4.8 and 2.4. From 4.8 to 2.4, you have to divide by 2. So that means that the ratio is times 2 for the cylinder, or divided by 2 for the cylinder. Now, if you look at the surface area, which you're given, that should be divided by then 2 times 2, since it's area, which is 4. So you should be able to take the surface area that you're given, divide it by 4, and you'll be given the new surface area of the new cylinder. Same thing for volume. Instead of 2 times 2, it'll be divided by 2 times 2 times 2, or 8. Take the old surface area divided by 8, and that will give you your new surface area. So the old surface area was 356. 356 divided by 4 is 89. And then if you take the volume of 507 divided by 8, that's about 63. It's like 63.37 or something like that, but it rounds to 63. Let's look at number 10. The ratio in the dimension change is 3/4 of the length. Remember, of means times. 3/4 times 3/4, since its area, is 9/16. Take that original shape, 6,000, multiply by 9/16, and that will give you your final answer. I'll let you do that. All right, let's look at number 12. So we know that Amelia sees 2 cubic sculptures. She estimates the edge length is between 2.5 and 3 times the edge of the smaller one. So to find the estimate of the volume, you would take 2.5 times 2.5 times 2.5. And you'd also take 3 times 3 times 3, because you know it's between those two numbers, and you know that volume is cubed. 2.5 times 2.5 times 2.5 is about 16. And 3 times 3 times 3 is about, or is 27. That means that it should be about between 16 to 27 times greater. Okay, so let's look at 14. Gina has 78 square feet of plywood. First of all, you need to ask yourself if that's surface area or volume, and that's surface area. It's the outside of the box. So how much plywood will she need to build a similar box? This one's working in the same exact way that you worked with the other one. You know that if it's half the dimensions, that means you're going to divide 78 by 4. All right, the last one that we're going to work through together is number 16, and it just works a little bit backwards. 2 prisms are similar. The surface area of one is 4 times the surface area of the other. So you know now that the area is 4 times that. So 2 times 2 is 4, so the ratio of the corresponding dimensions would have to just be 2 over 1 or 2. But since you have to write it as a ratio, you have to write it as 2 over 1.